Hello, my name is Richie Stagg. I'm Director of Sales and partner with EmissionRx, a Calgary-based company that designs, builds, and installs high-efficiency waste gas combustors solely for the use of greenhouse gas emission reduction. Paper today is entitled "The Use of Enclosed Combustion in Reducing Greenhouse Gas Emissions." As you may know, waste gas management is critical in oil and gas development. And we will be the first to admit that waste gas conservation should be the primary objective. However, in many cases, this is not economic to do so. And as a result, waste gas is dealt with in three ways. Venting is a very common practice still and poses some serious environmental and health risks, as well as major safety concerns. Flaring is a very common practice still in oil and gas. Some of the challenges associated with flaring find that there's often incomplete combustion of the waste gas, a lot of unburned hydrocarbons emitted as a result of incomplete combustion. Obviously the visible flame, black smoke odor, etc. Also challenges around effectively managing rich gas. By comparison, enclosed combustion offers another option for producers whereby the waste gas is combusted in an enclosed chamber. It's possible to measure the efficiency of this process. A number of advantages of this include it's able to effectively manage rich gas. There's increased safety around this type of a system, and it can effectively manage H2S, which can be a challenge for other types of management systems. In comparing waste gas combustion efficiently and waste gas combustion inefficiently, there's a number of notable differences. Looking at a basic combustion process whereby you have methane, addition of oxygen, and ignition source, the result is heat, CO2, and H2O. By comparison, inefficient combustion often results in unburned hydrocarbons, carbon monoxide, VOCs, particulate matter, so there is a significant difference in the two results. If we can agree that methane is 25 times more potent than CO2, then looking at an example of 500 standard meters cubed per day of methane, if you were to vent that, the result would be 3,097 tons of CO2 a year. By cleanly combusting this, and by cleanly combusting, I mean you're combusting at an efficiency rate of greater than 99.9%. You have a result of 337 tons. It's a 89% reduction. You can see there's 2,760 tons. This is equivalent to almost 600 vehicles off the road. So some pretty significant differences between efficient combustion and inefficient combustion. We've noticed that there is a growing need for energy to be delivered better. We see this through demands for greenhouse gas emission reduction. A number of legislative bodies, both national, local, state, provincial level, are bringing in tougher regulations around this. And producers are looking at ways in which they can cost effectively manage or cost effectively reduce their emissions. And to narrow that further, you can find that industry and government, I think, recognize that methane reduction is one of the most cost-effective ways to reduce greenhouse gas emissions. Half of the methane emissions come from direct venting or venting from equipment, while the other half from unintended releases of fugitive emissions. It's those 50% of methane emissions from direct venting and equipment that we are going to be targeting. And as I stated earlier, enclosed combustion is just one example of technology that can be used to effectively manage greenhouse gas emissions. Some of the advantages of enclosed combustion is that the results are quantifiable. It's possible to measure quite accurately the efficiency rate and what the end result will be of your waste gas combustion. It's very easy to be compliant regardless of the regulatory rules, whether they're state, provincial, federal. Minimal environmental impact, as we stated earlier, the results of efficient combustion or effective combustion of basically heat, CO2, and water. It also provides operators with social license to operate, and I'll discuss this a little further. So enclosed combustion is an example of technology that has been used and is continuing to be used in all sectors of oil and gas in terms of extraction, processing, and distribution. You can see by the diagrams there or the photos that in upstream you're seeing use of enclosed combustion in well flowbacks, drilling, completions. Typically in these types of applications, you're finding rather significant amounts of gas that is being combusted. In some cases, one combustor may be responsible to manage between 4 and 5 million a day of gas. So it's these are large units designed for some pretty robust types of conditions. Midstream, you're getting into your processing, waste gas dehyes, storage tanks, etc., transportation. Also, there is a requirement, a need for effective management through enclosed combustion. And then when you get into downstream, of course, refining, I'm sure we've all seen cases of large refineries that have either flares or combustors that are looking to help to mitigate greenhouse gas reductions through the use of these types of devices. In addition, the opportunities for enclosed combustion are quite widespread, and they usually encompass a fairly wide variety of waste gas compositions and flow rates. In addition, you see enclosed combustion used in both permanent applications, such as process conditions or production equipment, storage tanks, gas dehydration, casing gas, and these units have been designed to really remain in place for an extended period of time. Temporary applications you'll find in flowbacks, well flowbacks, where they're looking to test wells, complete wells, pipeline blowdowns, well abandonments, which we're seeing greater interest in Eastern Western Canada, and facility turnarounds, where you bring in temporary pieces of equipment for short-term use. As I've stated, enclosed combustion continues to offer solutions for managing waste gas in many conventional ways, but we found that there are smaller, more problematic waste gas streams that are really posing a challenge for operators for a number of reasons. They are difficult to manage. Not only that, they're economically challenging because it's difficult to develop, or has been difficult to develop, a cost-effective solution when compared to some of the traditional combustion solutions that we currently see. These are characterized by tank vapors, casing gas, associated gas. Some of the characteristics of these types of applications are low volume, low pressure, varying flow rates, varying heat value, often very, very rich gas. And these types of waste gas streams are typically vented or flared. And again, these pose economic and environmental challenges when you use these types of solutions, venting and flaring. And again, collectively, they contribute to 50% of the greenhouse gas emissions. So a solution that we have developed for managing these problematic streams is what we've termed an application-specific enclosed combustion system. And by that we mean we have looked at the requirements that a producer has and have come up with a solution aimed at assisting them specifically in that type of an application. These types of systems provide for seamless integration into their operations. It's an immediate solution. And probably the most important thing is that it's cost effective, and this permits the producers to continue development safely, effectively, and under the jurisdictional guidelines within their operational areas. So we addressed the challenge of some of these problematic streams. We were approached by a number of producers to develop, again, what we've termed application-specific combustor designs. Our initial entry into this market was our RC system, proved quite acceptable to the producers here in Western Canada. Had some success with these units on sort of larger facilities, but we're approached by a number of producers in Western Canada here to look at ways that we can develop application-specific units for very, very small waste gas streams. And again, these were problematic streams that were typically vented and flared, not very successfully though. And again, cost was key. So following the development of our RC series, we developed the C series, EF series, and most recently the E series. And the C series, EF series, extensive implementation in Western Canada, Saskatchewan, Alberta. Most recently, the E series has made its way down into Colorado, so we're grateful for the opportunity to assist producers in that area. Again, all of these systems have been designed to focus on some of these more problematic waste gas streams that producers have struggled with managing effectively. Number of standard features that our combustors offer in terms of a natural draft, there's no fans or blowers, a way to manage entrained liquids, a continuous pilot. There's a number of safety features that we've incorporated in terms of inline flame arrestor, freestanding, no guy wires, no high temp refractory, which means that there's some significant cost savings. No assist fuel, etc. So there's a number of standard features that all of our units offer. Again, we are 99.9% combustion efficiency with no flame, smoke, or odor, and we are compliant with all regulatory bodies. On the topic of regulatory bodies, there's a number of regulatory changes that we have seen in Western Canada and in a number of US states. And again, the common thread throughout these regulatory changes is that these bodies are looking at ways that they can reduce greenhouse gas emissions, notably methane. And one of the ways in which they're looking at reducing the methane emissions is focusing on what is currently being vented. And we're seeing that in Alberta, for example, there's going to be some changes coming in 2022 whereby producers are going to be significantly limited to how much gas they will be allowed to vent per site. Currently, Saskatchewan has some very rigid gas vent limits in place. And again, it's a challenge for these producers to come up with a solution that's going to be cost effective and maintain compliance. Again, with the use of small application-specific combustors, we were able to assist our clients with the management of these streams. Colorado, most recently, is looking to reduce gas emissions rather significantly by 90% by 2050. The recent rules on storage tanks and uncontrolled VOC emissions posed a real challenge for operators there. 2 tons per year, or 2 tons with a potential to emit, is a very, very small amount of gas. And again, the legislative bodies were focusing on these problematic streams, smaller flow rates. And again, we were able to assist with that. North Dakota is bringing in new laws as well in terms of reducing VOCs by 95%. New reporting requirements, and again, these are focusing on these problematic streams from storage tanks. New Mexico currently looking at developing rules around regulating methane emissions. They're in a rather enviable position in that they can look at what other jurisdictional areas have done, what they brought in, what's worked, what hasn't worked, And the New Mexico Methane Advisory Panel is working diligently with industry and stakeholders to develop a framework for effective not only production of the hydrocarbons, but also effective management of the waste gas that's often associated with that. Going back to the previous slide in terms of effective versus non-effective, just looking at the amount of waste gas that is being vented or flared in the Permian, which is a large basin located between in Texas and New Mexico. Same principle applies here, same formula applies. But if we assume that, or we can look at the fact that venting and flaring in the Permian averages 661 million standard cubic feet a day of gas. If we assume 50% is vented, we're down to 300 million standard cubic feet a day of methane. Using the same principles of combustion efficiency of greater than 99.99%, looking at the amount of CO2 equivalent that is generated as a result of that gas being vented, seeing it's 52.6 million tons per year. If that is combusted, it's 5.7 million. So there's a significant reduction in CO2 equivalent down to 46.9 million tons. And astonishingly enough, this is the equivalent of removing 10 million cars off the roads. Texans won't like this, but there's over 8 million cars currently registered in the state of Texas. So be pretty clean air and empty highways down there if that was the case. Recognizing that while waste gas or gas is a resource, when you combust it, there does appear to be 4 options for utilizing waste heat. So in essence, that heat, which is a waste, now becomes a source of energy. One of the areas that we have looked at and have some experience with is water vaporization, whereby you are looking at produced water generated from drilling, which is typically re-injected down a well. Through water vaporization, there's an opportunity there to vaporize that water and put it back into the atmosphere with the remaining sludge being effectively and safely dealt with. Power generation through a TEG is another option that is currently being used. Waste heat can be generated or can be used to generate power. Heat tracing, of course, here in Western Canada, cold is an enemy of producers here in the wintertime. So heat tracing is another option that waste heat can be used for to assist in maintaining their operations. And finally, agriculture, again, this is being used now too, waste heat and CO2 used in developing food crops within greenhouses. I mentioned this earlier, but a social license to operate is another key element in producers being able to effectively develop their resources responsibly and safely. And the use of enclosed combustion does offer another number of safeguards to permit the producers to continue their operations within, oftentimes within very, very close range of homes, businesses, etc. So again, enclosed combustion offers a number of safeguards: no flame, smoke, odor. It's a very high waste gas combustion efficiency rate. Its results are quantifiable. We're compliant with all regulatory bodies. It's easy to integrate these types of combustors into a producer's operation. Significant cost savings. Oftentimes these are significantly less than the cost of a flare or a vapor recovery unit. And again, it's immediate and significant greenhouse gas reduction. Our company, while 3 years in operation, we have extensive experience in the waste gas combustion field, over 250 installations, primarily in North America. Our strength lies with our engineering team, 2 very talented mechanical engineers on staff All our in-house design, 3D modeling, and engineering drawings are performed by them. We work very closely with our regulators here, had some initial discussions with regulators in the US, and we're able to maintain our low costs by working closely with our fabricators, centralizing our fabrication, coating, assembly, and testing here in Calgary. Contact information is there. If there are any questions or anyone would like information on our products, how we can assist you, I'd be grateful for the opportunity to speak with you. And again, I'd like to thank Ray and his team, the Applied Energy Symposium, for allowing us the opportunity to present our information to you. And all the best.